unit number of AA180076. So today I will present to you my group simulation of my ground system for the CST subject for our project. So as you can see, the transfer function that we obtain for the calculation, first we need to determine by the value of transfer function equation by determining the value of top load over voltage and from the given data in the questions, and by doing some steps we can get the value of transfer function equation. Then we proceed to determine the value of k until by using the Ziegler-Nicholas second method, and then we can get the value of k, which is KCR equal to 173310870. Alright, then we can obtain the value of S, which is plus minus 7.7114. By using that value, we can find the value of period of oscillation, which is PCR, and then we can get 0.18 second. Okay, then we proceed to the Ziegler-Nicholas method, is the second method, which we can obtain, as you can see in the table 2. So here are the value of P, which tends to have the value of Kp, Ti, Ki, Td and Kd, and then we can observe the value of P, Pi and PID. So, and this value that has been obtained we used to in the system in the MATLAB simulator. So yeah, that's how the calculation can be obtained for the value of P, Pi and PID. Thank you. Back with me again. So today for this part I will explain to you our system for the subsystem, to obtain the value of overshoot, setting time, rest time, and peak time, and steady state error. So for this part, this is actually the main part for the project to obtain the value. So technically, as you can see in the MATLAB display right now, all of these are our overall system for the MATLAB simulator for this project. And then to obtain the value, this is the subsystem. In here is the subsystem of our transfer function that we have obtained for the calculation. Then we proceed to the system. So for here is the P manually, Pi and PID value. So this up here is actually the PID auto tuning to compare the value of the value we obtained, to compare the value. So I will explain to you the part of, for my part I will explain to you only the part of subsystem and the P system. So after we run the simulation, so to obtain the value, to observe the value that we must determine, we can see in the scope, which is, as you can see, for the overshoot time, for the first is the overshoot time, which is 0.505%, and then we proceed to settling time, 3.331 F seconds, and then for the peak time, we'll obtain here number 1 here, because this is the peak actually, and then we will 1, so the peak time would be 2.1. Alright, so that's for the subsystem scope, for the subsystem value. And then for the P, the value of the rise time would be 219.260 millisecond. The overshoot would be 55.469%, and the peak time is the 2.5 seconds. So yeah, that's for the subsystem and P. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shafiq bin Zakaria, and today I will do simulation for PI controller, PID controller for manual tuning, and PID controller for automatic tuning. So we move to the PI controller. So before that we need to run. I have run before recording because it will took a long time. So this is a graph for PI controller. So the peak value it is 9.86 second, and for the rest time it is 103.04 millisecond. The overshoot is 115.65%, and for settling time it has no value. So we move to PID controller for manual tuning. So this is the graph. So for the peak time it is 1.540 second. The rest time is 179.537 millisecond. The overshoot is 80.91%, and also the settling time we have no value. Next, we move to the PID controller for automatic tuning. So the peak time it is 4.208 second, and the rise time is 1.216 second. For overshoot it is 0.505 second, and also for the settling time it has no value. So this is the parameter for PID controller for automatic tuning. For P, the value is 29.7794. For I, it is 5.082. And for D, it is 34.865. So that's all from me. Thank you.